Now let's go into our first example with lists. The first one is locker problem, which is an interesting problem which looks at like that, +1, and it's only going to care about the students that, only going to care about the actual multiple, right? So it's just going to, student 7, for example, is just going to care about 7, 14, 21, etc. So in that case we have this. And we're going to open it if it's closed or close if it's open, right? So what kind of elegant way can we use to write this? Essentially, we're going to look at the index, that particular locker, and we're going to set it to the not of itself, right? Which is a really nice, clear way of showing that if it's true, then make it false. If it's false, make it true. And finally, we have this list, right, of is open lockers, which is either a Boolean, which is a Boolean true or false, based on the index 0 all the way to locker +1. So now we need to return again a list of all the locker numbers that are open. So we need to return integers. Let's say that is something called open lockers, and that's an empty list. So we're going to loop through the index, right? Because we want to know the index of this open list, true, false. So for locker in is open, if this argument, if this particular locker is open, then you're going to append it to your list, right? So open lockers dot append the element, or sorry, the list index of the locker. And finally, you're going to return open lockers, right? Because we don't want a list that contains all true and false. We want to return the actual locker number. So because we started off with having the first locker being 0, and that's always staying closed because we're starting with student 1, that's not going to give us any problems with returning, right? So now we've essentially written a problem that takes in all lockers being false and then loops through cleverly by looking at students and only caring about the multiple of the locker that the student in question is opening or closing. And this simple line is exactly, embracing the kind of problem type this is, just the not of what is currently being looked at. And then with this is just a way to return the problem statement, which is a list of lockers that are open or closed. And actually, I'm just going to change this statement right here because for clarity, even though lockers equal students, we're just going to go through the students that are assigned. And let's actually test it out by looking at what, for example, 2,000 lockers would look like. Which ones will be open? And, oops, that's going to be students. And you get a list of all the lockers that are open, which are perfect squares.